Okay, then here is one topic, laws of motion and friction. Okay, so first of all, laws of motion means we actually introduced to you, it's a Newton's law, right? So first of all, the first law of Newton means what? The first law of Newton, that means actually all of you know hopefully is actually laws of inertia, right? So what is the laws of inertia? Laws of inertia means just a very simple situation. If a body is in rest, then actually try to rest in that position if until and unless you apply a force on that body. Just the picture here gives a block here, okay, and the block is rest, okay. Now the block is rest, and until and unless you just not apply the force, is a rest in position, okay. And it's actually first law. And the second part actually, if the block is in motion, then until and unless you just don't apply, it doesn't apply any force on it, then it continues to move. It is continuous to move with a straight line with the same speed. Okay, this is the first law of motion. Now next is the second law of motion. So what is second law of motion? Second law of motion means if you apply the force, then what will happen? If you apply the force on an object, then what will happen? So just imagine the block on the floor. The block here on the floor is in rest. Then you apply the force F. Then what will happen? It will move. Let's say its velocity right now, it's a v. Then actually now comes the second law of motion, that the change of velocity. That means change of velocity. Remember, it's a rest. I mean that initial velocity u is 0. That means the block is in rest. But change of velocity means what? Acceleration. And all of you know from your previous classes, that means acceleration actually depends on force and the mass of an object. That means force equals to, you can write it, mass into acceleration. Okay, so all of you know the force and the acceleration is actually vector quantity. See, if I write this equation in the another way, a equals to f by m, right? So f is a vector quantity, f means force actually, the force is vector quantity, a means acceleration, also a vector quantity, right? So if I drop some vector sign here, so a equals to f by m. Okay, so this equation actually for a single particle, right? So if is an object here, the mass a. So if I apply a force here f, so it's acceleration, because I just apply the force horizontally. So of course this acceleration should be horizontal, a here. Okay. Now, if there is a system of particles, or if I apply the force in any one direction or too much more direction, then what will happen? Just imagine if I apply the force on an object in 2 or 3 more directions. Let's for simplicity for 2 direction. So that's the object here, and I apply a force F1 in that direction, and F2, let's say perpendicularly in that direction, just a perpendicular force. Then what will happen? So actually the acceleration will be the algebraic sum of the force divided by its mass. Algebraic sum, that means a vector sum of F1 and F2 divided by its mass m. So it will be the acceleration of that object. Okay, now it is the second law of motion actually. Now how to calculate the pulley problems, the strain problems like this. So first of all, there are some tricks here. Number one, first of all, choose the system. Choose the system. Okay, no problem. What is the system? After that, the tricks. A lot of tricks here. Now I can elaborate. Okay. So after that, I can elaborate all the tricks here. So first of all, choose the system. Number two, draw all the forces on it, all the forces on the system. I mean all the force on it. Okay. The third step, just make a free body diagram. It's a very important. Make a free body diagram. Okay. Now, number 4. Choose a coordinate system. If it's a one-dimensional, then it's a very easy to choose. If it's a two-dimensional, it's a quite difficult, but it's a very simple. Okay. So number 4, it's a choose the coordinate system. Choose the coordinate system. And number 5, that I already explored, that I already tells on you that the acceleration means all the forces. Acceleration means all the forces acts on it divides by its mass. Okay, now I just explain just what is the meaning of this actually. So just let's deal with an example. Okay, so let's talk about just an example. Okay, so it's just imagine a bob, just a bob with a string just hanging with a lift, hanging in a lift, a bob and a string just hanging on a lift. It's a lift here and it's a string, it's a bob of, let's say it's a mass m. Okay, so just mass and the string hanging on the top of a lift. Okay, now just consider the lift goes down with an acceleration a, and I want to calculate the tension of that block. Okay, the tension that actually for the string, tension of the string on the block. Okay, so calculate tension, right? T. So first of all, our condition, choose the system. That I want to choose the block here because I want to calculate the tensional force on the block, I mean on the bob here. So first of all, it's my system. Okay, now draw the forces on the system. So it's a block. First of all, bob is my system here. So now just draw all the forces on the system. All the forces, right? All the forces. So first of all, it's a mass m here. So of course the gravitational force mg acts downward on the block. And all of you know, it's your previous class, the tensional force pull up. Okay. So it's the tension T Okay, so these are the forces T and mg. Now makes a figure diagram. I already draw the figure diagram here. Figure diagram means just the system actually. If you want to calculate the force on the system and acceleration of the system, something like this, the system, just make the system as a dot, right? System as a dot. It's the system. I mean, in our situation, it's the bob, just the dot. Here the two forces mg on it downwards and the gravity, I mean the tensional force T upwards. Okay, these are all the forces. Now choose the coordinate system. Now just is our simple case, simple situation is actually T and mg in just a one-dimensional situation. It's a very simple. So just it's a 1D movement. So it's a one-dimensional. Just I draw the one line that makes a one-dimensional case. And now acceleration means all the forces acts on it. That means acts on the system, acts on that block, divided by its mass. Now just imagine the block goes downward. Now which force acts larger? Of course mg, because mg is downward and the blocks goes downward. So mg is downward. Then of course if the block goes downward, then mg will be greater than tension, right? Because the mg is a downward, tension is the upward. So and the block goes downward. So mg should be greater than tension, right? So mg minus t. Why the minus t? Because all of you know from your previous class that it's a two vector. Force means vector. If it's a positive, then you should make it's a negative. And if you introduce mg as a positive quantity, then tension should be negative because the opposite direction mg and t. So if I draw mg as a positive quantity, because the bow actually goes downward, that means a acceleration will be positive. So mg minus t by m equals to acceleration. Then if I calculate, if I want to calculate tension here, then of course this is a very simple situation. It's just a cross multiplication. Mg minus t equals to ma, and t should be equals to mg minus ma. It is our tension. The tension on the bob when it moves, the lift moves downward. Okay. So these are actually tricks. The 5 tricks here to solve any problem like pulleys or string problems, block problems like this. It is the ball and nothing there in it. Okay, just nothing there. Okay. Now and then lot of there actually laws of motion is a very vast chapter. Lot of there I don't have enough time to introduce to you actually. I have a very limitation. Okay. Now there is a third law of motion. I mean action reaction pair. What is action reaction pair? All of you know. If I hit the board here, then I just actions on it, and the board actually reactions, just a counter attack on my hand. It is called reaction. And all of you know very simple. The action and reaction doesn't act on a same object, because actions on the board and the reactions is on my hand, right? Okay, so it's our case. Now I introduce to you the friction, right? So from your class 8, 9 or 10, somehow 10, it's your syllabus that the friction means what? The interlocking of the two surfaces. Just the interlocking. Okay, just imagine if there are two smooth surfaces, then what will happen? That's just a two smooth surfaces. To smooth surface means there is an atomic arrangement. The molecular arrangement or atomic arrangement is a very smooth. I mean, just imagine it's a surface and it's a smooth surface. That means atomic arrangement is the very smooth, like this. It's the atom of that surface. Okay, it's a very smooth one, very smoothly arranged. Now, if I place a block here and the surface of the bottom of the block is a very smooth, then what will happen? All of you know actually. Okay, I just blocked this block. I mean the atom. Okay, I just designed the blocked atom or the block. Now what will happen? Just imagine. For our gravitational sense, each and every atom of the block has a mass, right? Very little mass, very little, but it has a mass. Then Earth actually here pull it down, and of course by your sense of Newton's third law, that the atoms of that surface actually pull it up because action reaction pair. So actually the surface, I mean the atoms of the surface push the block upwards. It is called normal reaction. It is called what? Normal reaction. So here the case, if the surface of the two quantities, I mean here is a surface of a floor and the surface of the block is a smooth, then there is only one case happen. The block, the atoms of the block depressed the surface of the floor and the surface of the floor push it down. It's called normal reaction. Okay, then what will happen if there is irregularities? I mean atomic arrangement or molecular arrangement is not the regular. Okay, now what will happen? Just see. Let's say it's the floor of our house, it's the floor of our flat. So what will happen? If you imagine it or if you see the microscopically, then there is the irregularities. This is not a smooth surface. It's the irregularities here. I mean, kind of this structure. One atom is here, one atom there. Lot of it's the irregular structure. Then what will happen? If I place a block here, then the block surface also, the bottom of that block surface also there is a irregularities. Okay. So ultimately what will happen actually? There is a not exactly in the universe, in the earth there is a smooth surface, right? So that doesn't exist in the smooth surface. Okay. So irregularities there. So I mean if I draw the atoms of that block, so there is an irregularities. Now what will happen? Just see that part. Just a special part I draw here. Just see that part. So there is, I just zoom in that portion. So what will happen? If I zoom in that portion, then there is a white atoms of the surface and the floor, and the blocked atoms means the atoms of that block. Then what will happen? The block actually not just a vertical force, but it actually some standing force on it, because it's push it, right? It's push it not vertical, but it's landing. So of course in an action-reaction pair, these atoms of the surface, of course, get that force, the pull back, push back in the inclined force. Now if I imagine this force as a two component here, so one is a normal component, one is a horizontal component, I mean the tangential component. So it's just a situation here. So that's a reaction force. It is a reaction force. It has a two components. It is called the normal reaction, and it is the tangential force. It is called the frictional force. Okay. So if there is an irregularities of the two surfaces, then the frictional force will appear. Okay. Now there is a three types of friction you can encounter here. Okay, one is the static friction, one is the kinetic friction, and number third is the rolling friction. Right? So what is the, first of all, just imagine what the kinetic friction. Kinetic friction means, what is mean by kinetic? Kinetic means an object is just moving, right? It has a speed. That means a kinetic. That of course all of you know for the kinetic energy. Kinetic energy means half mv square. That means a v, the velocity is related. So actually the kinetic means the body moves. Okay. So if is a surface, I mean the floor, and it's an object. So if the object moves right or left, so then the friction that appears on that block, on that object, this is called kinetic friction. So just imagine how this kinetic friction appears. So if I draw the atomic arrangement of these two, I mean the floor and the block, then what will happen? Just imagine. It's an irregular surface of the floor, and now just it's a block. Then what will happen? So if the block wants or try to go in that position, I mean try to one shift, try to go from here to there, then what will happen? It just draw some atoms here. Then what will happen? Okay, now just see this portion. If the block try to move here, then this kind of atom actually push this atom, white atom, I mean the atom of the surface. So of course by the action reaction pair, these atoms, white atoms, I mean the atom of the surface, of course get that force on the block. Okay. So that means a frictional force. So if a block try to move left, the frictional force on the block by that floor actually that opposes the motions, and it actually opposite, I mean towards the right side of the block. Okay. So it is called the kinetic friction. Then the static friction. What is the static friction? So static friction means, let's say static means what? All of you know static means the state of rest, right? So actually just imagine an almirah, just an almirah, it's a heavy object. Okay, heavy object that stands on a floor, rough floor, of course a rough floor, right? It's a rough floor. Now if I want to push the almirah by 10 Newton force, then just by seeing that situation, then of course the almirah can't move. So why can't move? I just gave a force of 10 Newton right on the right direction, but the almirah doesn't move here. Why? Because the almirah, surely the almirah gets an opposite forces of 10 Newton by the floor, right? And then the 10 Newton in the right side and the 10 Newton the left side cancels out, right? Okay. Now, if I granted a 15 Newton